Good day everyone. Welcome to today's lecture on Enterprise Resource Planning and Supply Chain Integration. I hope you are all ready to explore how modern businesses use integrated systems to manage their operations effectively. Let me start with a question. How many of you have ever wondered how companies like Grameenphone manage to handle millions of customers, process payments, and coordinate with suppliers all at the same time? The answer lies in what we are going to discuss today, that is ERP systems and their integration with supply chain management. So what exactly is ERP? ERP is a packaged software solution that addresses the enterprise needs of an organization by tightly integrating the various functions of an organization using a process view of the organization. ERP software is ready-made generic software. It is not custom-made for a specific firm. ERP software understands the needs of any organization within a specific industry segment. Think of ERP as the central nervous system of a business. Just like your own nervous system coordinates all parts of your body, ERP coordinates all departments of a company. Many processes implemented in an ERP software are core processes such as order processing, order fulfillment, shipping, invoicing, production planning, bill of material, purchase order, general ledger, and so on, that are common to all industry segments. For example, when you place an order with an e-commerce company like Peekaboo.com in Bangladesh, the ERP system immediately updates inventory levels, triggers the fulfillment process, generates shipping documents, updates financial records, and even helps plan future inventory needs. All of them are done automatically and in real time. Now, we will talk about how ERP connects the functional units. Common ERP modules include modules for product planning, parts and material purchasing, inventory control, product distribution, order tracking, finance, accounting, marketing, and HR. Organizations often selectively implement the ERP modules that are both economically and technically feasible. Let me walk you through the key ERP modules. Firstly, we will talk about the ERP production planning module. As manufacturing requirements planning evolved into enterprise resource planning, software vendors developed stronger tools for production planning, while consulting firms gained extensive expertise in implementing these modules. The production planning module helps companies optimize the use of manufacturing capacity, parts, components, and material resources. It relies on historical production data and sales forecasts to ensure resources are used efficiently and production meets demand. Consider how Alton uses production planning modules to coordinate the manufacturing of our refrigerators, our air conditioners, and other appliances across their different facilities and ensures they produce the right quantities at right time. In the ERP purchasing module, the procurement of raw materials becomes more streamlined and efficient. The system automates key tasks such as identifying potential suppliers, negotiating prices, awarding purchase orders, and handling billing processes. This module works closely with inventory control and production planning to ensure materials are available when needed. It is also often integrated with broader supply chain management software to create a seamless flow of information across the entire organization. In the ERP inventory control module, companies can maintain the right level of stock in their warehouse. The module supports activities such as identifying inventory requirements, setting stock targets, choosing replenishment techniques, monitoring item usage, reconciling stock balances, and reporting inventory status. When integrated with sales, purchasing, and finance modules, the inventory control module enables ERP systems to generate accurately and timely executive-level reports. In the ERP sales module, revenue generation takes center stage as it forms the lifeblood of commercial organizations. The module manages key functions such as order placement, order scheduling, shipping, and invoicing. It closely integrates with an organization's e-commerce platforms, ensuring a smooth flow of sales operations. Many ERP vendors also provide online storefronts as part of the sales module to support digital sales channels. Under ERP marketing module, companies gain support for activities such as lead generation, direct mailing campaign, and more. In the ERP financial module, both for-profit and non-profit organizations benefit from its use. This module acts as the core of most ERP systems and collects financial data from different departments and generates important reports including the balance sheet, general ledger, trial balance, and quarterly financial statements. The ERP HR module is one of the most widely implemented ERP modules, and it streamlines the management of human resources and human capital. The module maintains a complete employee database including contact information, salary details, attendance records, performance evaluations, and promotion information for all employees. ERP systems are all-in-one software suites that help companies manage nearly every aspect of their business. This includes overseeing the supply chain, which involves a complex set of interdependent activities such as analyzing demand, sourcing materials, manufacturing products, and distributing them to final customers. Leading ERP systems include modules that handle key supply chain management functions such as planning, procurement, manufacturing, inventory management, warehouse management, and order management. They also enable businesses to coordinate, streamline, and automate these activities so they can consistently meet consumer demand while reducing operating costs. Because ERP systems store all business data in one single database, companies gain a unified view of supply chain operations alongside their financials and other important information. The integration among ERP modules help companies better plan sourcing and manufacturing based on consumer demands. This built-in integration also reduces or eliminates the challenges typically associated with integrating multiple applications to handle different supply chain functions. ERP systems also enable companies to automate supply chain operations, leading to time and cost savings while reducing the risk of human error. Integration among ERP modules improves the flow of information between business units, making teams more collaborative and efficient. For example, access to accurate data on supplier contracts, supply chain capacity, and customer demand helps procurement managers buy the right quantities of raw materials to maximize output and meet consumer commitments, all while keeping the costs under control. There are some key points to remember. Firstly, ERP systems with supply chain management capabilities help businesses match supply to customer demand, reduce operating cost, and respond quickly to changing market conditions. Secondly, leading ERP systems include modules that streamline and automate supply chain activities such as planning, procurement, inventory management, warehouse management, and even order management. Finally, by using ERP modules for supply chain management, companies gain a unified view of business data and face fewer challenges with application integration. Implementing supply chain management and ERP integration requires a careful consideration of functionality, scalability, and implementation complexity. Cloud-based ERP solutions are often a better fit than on-premises systems for many businesses because they do not require companies to buy, implement, and maintain on-site hardware and software. There are a number of indicators that serve as vital signposts offering insights into the effectiveness of an integrated ERP system. Some important points to keep in mind when evaluating ERP software include the functional fit with the company's business processes, the degree of integration between system components, flexibility and scalability, user-friendliness and ease of implementation. Other considerations include the ability to support multi-site planning and control, client or server technology capabilities, database interdependence, security, availability of regular upgrades, and the amount of customization required. Additionally, it is important to evaluate the local support infrastructure, the reputation and sustainability of the ERP vendor, and the total costs, including licenses, training, implementation, maintenance, customization, and hardware requirements. MRP was the fundamental concept of production management and control in the mid-1970s and considered as the first stage in evolution of ERP. Assembly operations involving thousands of parts, such as automobile manufacture, led to large inventories. The need to bring down the large inventory levels associated with these industries led to the early MRP systems that planned the order releases. Such planned order releases ensured proper time phrasing and accurate planning of the sub-assembly items, taking into account complex sub-assembly to assembly relationships characterized by the bill of materials. A typical automobile plant with hundreds if not thousands of parts has to face problems that are in order of magnitude even more difficult. MRP systems address this need. Using the processing power of computers, databases to store lead times and order quantities and algorithms to implement bill of material explosion, MRP systems brought considerable order into chaotic process of material planning in a discrete manufacturing operation. Manufacturing resource planning too addressed the entire manufacturing function and not just a single task within the manufacturing function. MRP2 systems could determine whether a given schedule of production was feasible not only from material availability but also from other resource point of view. Material requirements planning is a system for calculating the materials and components needed to manufacture a product. It consists of three primary steps. First, taking inventory of the materials and components on hand. Secondly, identifying which additional ones are needed. And thirdly, scheduling their production or purchase. Demand forecasts form the basis of all supply chain planning. All push processes in the supply chain are performed in anticipation of customer demand, whereas all pull processes are performed in response to consumer demand. For push processes, a manager must plan the level of activity, be it production, transportation, or any other planned activity. However, for pull processes, a manager must plan the level of available capacity and inventory, but not the actual amount to be executed. In both cases, the first step a manager must take is to forecast what customer demand will be. Mature products with stable demand, such as milk or paper towels, are usually easiest to forecast. Forecasting and the accompanying managerial decisions are extremely difficult when either the supply of raw materials or the demand for the finished product is highly unpredictable. Companies and supply chain managers should be aware of the following characteristics of forecasts. Forecasts are never completely accurate and should always include both the expected value and a measure of forecast error. Long-term forecasts tend to be less accurate than short-term forecasts, meaning that they generally have a larger standard deviation of error relative to the mean. Aggregate forecasts, on the other hand, are usually more accurate than disaggregate forecasts because they have a smaller standard deviation of error relative to the mean. In general, the further a company is up the supply chain, or the further it is from the end consumer, the greater the distortion of information it receives. Components of forecasting methods include past demand, lead time of product, planned advertising or marketing efforts, state of the economy, planned price discounts, and actions that competitors have taken. Forecasting methods are classified according to 4 types. Firstly, we have qualitative forecasting methods that are primarily subjective and rely on human judgment. They are most appropriate when little historical data is available or when experts have market intelligence that may affect the forecast. Secondly, we have time series forecasting methods that use historical demand to make a forecast. They are based on the assumption that past demand history is a good indicator of future demand. We also have causal forecasting methods which assume that the demand forecast is highly correlated with certain factors in the environment. For example, product pricing is strongly correlated with demand. Next, we have simulation forecasting method that imitates the consumer choices that give rise to demand to arrive at a certain forecast. An organization can perform effective forecasting by following a 6-step approach. First, it should understand the objective of forecasting to ensure that all efforts align with business goals. Secondly, demand planning and forecasting must be integrated throughout the supply chain to maintain consistency and accuracy. Thirdly, the organization should understand and identify different customer segments as demand patterns often vary across groups. Fourth, it is also important to identify the major factors that influence the demand forecast, including market trends, seasonality, and external conditions. Fifth, the organization must determine the appropriate forecasting technique that best fits the data and objectives. And finally, performance and error measures should be established to evaluate the accuracy and effectiveness of the forecast. Let's understand the time series forecasting method. The goal of any forecasting method is to predict the systematic component of demand and estimate the random component. In its most general form, the systematic component of demand data contains a level, a trend, and a seasonal factor. The systematic component of demand can be calculated in different ways. In the multiplicative approach, it is found by multiplying the level, the trend, and the seasonal factor. In the additive approach, it is calculated by adding the level, the trend, and the seasonal factor. And in the mixed approach, the level and trend are first added together and then multiplied by the seasonal factor. Static methods assume that the estimates of level, trend, and seasonality within the systematic component do not vary as new demand is observed. Forecast errors contain valuable information and must be analyzed carefully for 2 main reasons. First, managers use error analysis to determine whether the current forecasting method is accurately predicting the systematic component of demand. And secondly, all contingency plans must take forecasting errors into account to ensure that the organization can respond effectively to unexpected variations in demand. Now, we will talk about the role of IT in forecasting. There is a natural role for IT in forecasting given the large amount of data involved, the frequency with which forecasting is performed, and the importance of getting the highest quality results possible. The forecasting module within a supply chain IT system, often called the demand planning module, is a core supply chain software product. Commercial demand planning modules come with a variety of forecasting algorithms which can be quite advanced and are sometimes proprietary. These methods often give a more accurate forecast than what can be produced through the use of a general package such as Excel. Now we will talk about managing demand and supply in supply chain, and we'll also talk about aggregate planning problem. The objective of the aggregate plan is to satisfy demand in a way that maximizes profit for the firm. We can state the aggregate planning problem formally as follows. Given the demand forecast for each period in the planning horizon, determine the production level, inventory level, and capacity level for each period that maximizes the firm's profit over the planning horizon. An aggregate planner requires information including demand forecast for each period, production costs, labor costs, cost of subcontracting production, cost of changing capacity, labor and machine hours required per unit, inventory holding cost, stock out or backlog costs, and various constraints. Now, we will talk about the aggregate planning strategies. The aggregate planner must make trade-offs among capacity, inventory, and backlog costs. There are three main aggregate planning strategies. First, the chase strategy uses capacity as the lever. In this approach, the production rate is synchronized with the demand rate by varying machine capacity or by hiring and laying off employees as demand changes. Second, the time flexibility strategy uses utilization as the lever. This approach is suitable when there is excess machine capacity. The workforce remains stable, but the number of hours worked is adjusted over the time to match the demand. Third, the level strategy uses inventory as the lever. Here, machine capacity and workforce remain stable, producing at a constant rate, while shortages and surpluses are absorbed through fluctuations in inventory levels over time. There are several key recommendations for effective aggregate planning. First, think beyond the enterprise and consider the entire supply chain to ensure smooth coordination and efficiency. Second, make plans flexible, as forecasts are never completely accurate and adjustments will always be necessary. Third, rerun the aggregate plan whenever new data emerge to keep planning aligned with current conditions. Finally, use aggregate planning more actively as capacity utilization increases to optimize resources and avoid bottlenecks. Now, we will discuss the role of distribution in the supply chain. Distribution refers to the steps taken to move and store a product from the supplier stage to a customer stage in the supply chain. Distribution occurs between every pair of stages in the supply chain. Distribution is a key driver of the overall profitability of a firm because it affects both the supply chain cost and the customer experience directly. Now, we will discuss and talk about the factors influencing distribution network design. At the highest level, performance of a distribution network should be evaluated along two dimensions: customer needs that are met and cost of meeting customer needs. Customer needs in the supply chain include factors such as response time, product variety, product availability, customer experience, time to market, order visibility, and returnability. Supply chain costs that are influenced by the design of the distribution network include inventories, transportation facilities, handling, and information costs. Network managers must make two key decisions when designing a distribution network. The first one is, will product be delivered to the customer location or picked up from a preordained site? And the second one is, will product flow through an intermediary? And based on these decisions, 6 distinct distribution network designs may be used. Firstly, manufacturer storage with direct shipping. Secondly, manufacturer storage with direct shipping and in-transit merge. Third, distributor storage with package carrier delivery. The fourth one is distributor storage with last mile delivery. Fifth is manufacturer or distributor storage with customer pickup. And finally, retail storage with customer pickup.